All right, here in lesson 8-2, we're covering exploring f of x plus k in parentheses. Now, in the previous lesson, we learned what the effect of adding a k outside would affect it, and it did a vertical translation. We either moved up or down depending on the sign, and we moved the number of units. Here in this lesson, we're going to split the lesson into 3 separate sections. We're going to cover questions 1 to 5, questions 6 to 10, and then question 13 by itself to wrap up the lesson. Number 1 through 5's introduction. The function f of x equals the absolute value of x is graphed below. An absolute value function is written as f of x equals absolute value of x is defined by f of x equals negative x if x is less than 0, and f of x equals x if x is greater than or equal to 0. The vertex of an absolute value function is an example of a cusp in a graph. A graph has a cusp at a point where there is an abrupt change in direction. Number 1, write a new function g of x by replacing x with x plus 7. So instead of having just x inside my absolute value bars, we're going to put x plus 7 inside my absolute value bars. So we're going to call this g of x equals absolute value x plus 7. It says, number 2, graph both f of x equals the absolute value of x and g of x on a graphing calculator and sketch the graph of g of x on the grid above, labeling at least a few points in each graph. All right, well, we're going to clear out the calculator then. All right, absolute value you have to find. I'm going to go to math, over to number, and my first option is ABS, meaning absolute value. And it's actually going to put those bars in for me. The first one is x by itself. Again, we're going to go to math, over to number, and the first option is absolute. This time we're going to put in x plus 7. And I'm going to zoom 6 because I've been playing with the calculator, so I've been changing my window. But this takes me back to the standard window. Y'all should have been in the standard window. It should not have changed. This blue graph is the original. The one that hits at the origin, that's my original. What happened to the red graph whenever I placed x plus 7 inside? Because we want to graph that. So again, I can trace, but I need to make sure I'm on the right graph. So I'm on the red graph. I'm going to type in 0. At 0, the value is 7. So 0, the value is 7. Let's take a look. Let's try in negative 5. At negative 5, the value is positive 2. Okay, let's try negative 7. At negative 7, the value is 0. Okay, it wants us to give a few points, so I'm going to go to like negative 10. Negative 10 is at a positive 3. And on my graph, if I put in something bigger than negative 10, it's not going to graph it for me because my window is not that big. So I'll go with negative 9 just to see where it is. It's at positive 2. Now notice how straight these lines should be. So I got a straight line going this way, and a straight line going this way, like so. So I'm going to put C, graph, above. What is the x-intercept of the original f of x equals absolute value of x? Where does it cross the x-axis? At 0, 0. What is the x-intercept of the new function? The new function touches the x-axis at -7, 0. Describe the transformation of the graph from f of x to g of x. Would you say that this graph moved up? Nope. Would you say that this graph moved down? Nope. Would you say that this graph moved right? Nope. Therefore, I guess I can conclude that this graph shifted to the left. The graph moved 7 units left. Take a moment to get this copied down. On the next slide, you're going to see a debriefing question.